Hey guys, welcome back for another chemistry lesson. This video is specifically about the periodic trends of electronegativity and electron affinity. So, electron affinity is basically how much an atom likes gaining electrons, and we measure that based on the amount of energy that is released when we add an electron to a neutral atom. So, this is always done in the gaseous state. We have whatever it is, we add an electron to it, and so we get the ion plus whatever amount of energy is that electron affinity. So it's defined as exothermic. Sometimes it's actually endothermic, but anyway, we call it exothermic. There are some alkali earth metals and noble gases that are endothermic. But basically, the more the energy is released, more energy that is released, so the more negative a number, the larger the electron affinity, the more that atom likes electrons. So, all of this to say, basically, our alkali metals have a trend. They decrease as they go down the column. But this is only generally speaking, because this is the least reliable, the least consistent of the periodic trends. We do know that the highest electron affinity in any period is the halogen in that period. But yeah, we don't talk about electron affinity a ton in this class. Here you can see that our halogen by far has the most negative number in the row. So, and then we have positive numbers for our noble gases because we actually have to put energy in to force them to take an electron. The much more discussed periodic trend is electronegativity. Now, this is a picture that I got from Wikipedia, but there's the Pauling scale where we measure a value for electronegativity. And what that tells us is how much our atoms will, how hard they'll pull electrons from other atoms, right? So the higher the number, fluorine being our highest, here you can see 3.98, the higher the number, the harder that atom's going to pull on electrons whenever we're doing a bond. So this electronegativity is specifically related to ionic or covalent, and then are we talking about a pure covalent bond or a polar covalent bond? So this is a really important chart, and I'm not going to say it's a more important periodic trend, but this is the one that we use to talk about it. So for electronegativity, as we go down a period, that number decreases. So our least electronegative atom is going to be in the bottom left-hand corner. As we go across from left to right, our electronegativity increases. So our most electronegative atom is in the upper right-hand corner, and we generally don't think about our noble gases even having an electronegativity value, although clearly here some do. They don't bond, so there are actually periodic tables that leave this piece off altogether when talking about electronegativity. So the trends are, as I go from left to right, electronegativity increases, and as I go from top to bottom, it decreases. Most electronegative, upper right-hand corner, least electronegative, bottom left-hand corner.